Matrices. Question number 1. If A equal to 3, 1 minus 4 minus 1, then prove that A power n equal to 1 plus 2n minus 4 and n 1 minus 2n. Here we are going to use the principle of mathematical induction. So let's write n equal to 1. So A1, that is A, will be equal to 1 plus 2 into 1, that is 3. And here it will become minus 4 and 1, and this will become minus 1, which is true. Value obtained from here is equal to value of A. Now let's find out A square. So here we are going to put n equal to 2. So we will get 1 plus 2 into 2, 4 is 5. And if we write 2 here, it will become minus 8. And this will become 2. And this will become 1 minus 4 minus 3. Now let's see whether we are getting same result from here. So we get A square equal to A into A. We put the values. So A is 3 minus 4, 1 minus 1 times 3 minus 4, 1 minus 1. Let's multiply. So 3 to the 9 minus 4 means 5. 3 to the 12 minus 12 plus 4. It will be minus 8. 1 3 to 3 minus 1, which is 2. And the 1 into minus 4 is minus 4 plus 1, which is minus 3. Clearly, A square obtained from here and A square obtained by direct multiplication, both are same. Now let's assume that A power k is true. So if A power k is true, then we have to prove that A power k plus 1 is also true. So let's write A power k. A power k means 1 plus 2k, k minus 4k, and 1 minus 2k. Then A power k plus 1 will be directly obtained from here. 1 plus 2k plus 2 minus 4k plus 1, and this is k plus 1, and 1 minus twice of k plus 1. So if we simplify, we will get 2k plus 3 from here, minus 4k minus 4 from here. It will be k plus 1, and this will become 1 minus 2k minus 2, and that is minus 2k minus 1. So let's try to get this result by multiplying A power k to A. So A power k times A power k is 1 plus 2k, k minus 4k, and 1 minus 2k, and A is equal to 3 minus 4, 1 and minus 1. So A power k plus 1 equals, this will become 3 plus 6k minus 4k. From here it will become minus 4 minus 8k plus 4k. And this will become 3k plus 1 minus 2k, and this will become minus 4k minus 1 plus 2. So it will be equal to 2k plus 3 And what will this? This will be minus 4k minus 4, and this will become k plus 1, and this will become minus 2k minus 1. Sorry, minus 2k minus 1. Clearly, both results are same. So we can say that it will be true for any value of n. Now let's go to next question. Question number 2. Let a equal to 0, 0, 1, 0. Then show that ai plus ba power n equal to a power ni plus na minus 1 times ba. So let's check it for n equal to 1. So when we write n equal to 1, what do we get? We get ai plus ba in LHS and in RHS, n equal to 1. So this will be ai plus this will become n equal to 1, a power 0 will become 1, so ba. So it is true for n equal to 1. Now let's try it for n equal to 2. So here ai plus ba power 2 equal to a square I square plus b square a square plus twice of ai b a. So this will be equal to a square I plus b square a square plus 2ab. This is LHS. Now consider RHS. So when we put n equal to 2 here, so we will get a power 2I plus 2. So from here this will be 2 times ABA, that is 2ABA. But we are not getting this term. So in order to check this term whether it is 0, if it is 0, then both will be equal. So let's multiply to get a square. So a square 0, 1, 0, 0 times 0, 1, 0, 0. So if we multiply, so it becomes 0, then this will be 0, and then right now 0, 0. Yes, we are getting 0, 0. It means both are equal. We assume that it is true for n equal to k, and then we have to prove that it is also true for n equal to k plus 1. So if ai plus ba power k is true, so then we write a power k I plus k a power k minus 1 ba. Now we have to prove that k plus 1 is also true. So in LHS, we have to find out ai plus ba power k plus 1, and that should be equal to a power k plus 1 I plus k plus 1 a power k and ba. So let's try to prove from here that LHS is equal to RHS. So here ai plus ba power k plus 1 can be written as ai plus ba power k times ai plus ba. Now ai plus ba power k is given by a power k times I plus k a power k minus 1 ba, and then we have to multiply by ai plus b. So our concern is to get this result. So For this, we are going to multiply. So when we multiply this here, so it will become a power k plus 1 I square. I square will become I. And then when we multiply this here, so it will become k times a power k ba. Then we multiply by ba, so it will become b a power k and then a, because ia, whenever I is multiplied to any number or any number, in that case we don't write it. So we have multiplied ba to a power k times I. So here b times a power k times a. Now we are going to multiply by ba to this number. So it will become k times k times a power k minus 1. Here b will become b square and a square. Now we know that a square equal to 0. So if a square equal to 0, then this term will vanish. We are left with three terms. So let's simplify. So e power k plus 1 times I plus. From here, we can take out a power k ba. Then here we will get k and here we will get 1. So clearly by multiplication, we are getting same result as by putting n equal to k plus 1. So we can say that it is true for any value of n. Hence, we have got our result. Thank you for watching.